Okay, so calculating distance. It says the farther away that a seismograph is from the focus of an earthquake, the longer the interval between the arrival of the P and the S waves is. So we can use a time and distance graph to show the average times for S and P waves and then calculate the distance from that. So this is exactly like you can imagine you're running a race and somebody is much faster than the other person. So in this case, right, we would have the P waves would be much faster. And I know this is kind of hard to see because normally we place distance on the x-axis and time on the y-axis, but we're doing this the other way, and the reason for that is because we know the time and we want to know the distance versus the other way around. So here we go. So you kind of have to just imagine this kind of flipped, but in this particular situation, because that P wave is traveling farther in a shorter amount of time, that's why it looks the way that it is, right? So even though the P waves are faster, in this particular orientation, they kind of look like they're slower. Anyways, so you can imagine that you and a friend are running a race, and you are the faster friend, okay? So if you start running a race, depending upon where that race ends will determine how much time there is between your arrival and your friend's arrival. The farther the race, assuming you are running at the same speeds the whole time, the farther the race, the more of a time difference, okay? The shorter the race, the less of a time difference. And that's strictly because of the speed that you are running at. And that's exactly what is being used here, is this idea that the farther away that you are, there will be a longer time interval because the P wave travels at a particular speed, so does the S wave, so there would be a particular amount of time between the two there. And that's what this is talking about in particular.